Here we have a projectile launched horizontally from a height of 62 meters. So this dimension right here is 62 meters. The range is measured to be 238 meters. We know that when we say the range, we mean how far horizontally. So that means that this cannonball, or whatever it is going to land right about there, where that dimension is 238 meters. So this projectile is going to go kind of like that, and we want to find the launch speed. What are these variables? The launch speed is Vx. The 62 meters is dy. That's the displacement in the y direction. And remember, whenever we're talking y direction, it's important to define a sign convention that we're going to go by for this particular problem. Many of us are going to want upward to be positive, and that's fine. If you want downward to be positive, you can do that. I'll go ahead and make upward positive for this problem, which means this projectile is moving in the negative direction with regard to y. It's going down, so you have to put negative 62 there. If you make your positive convention to point downward, then it's okay to make this 62 meters. We also know the acceleration in the y direction. We're going to always assume that we're on Earth unless we're told otherwise. And which way does the acceleration vector point? Well, the acceleration is due to gravity, and gravity pulls downward. So once again, according to the sign that we've chosen, the sign convention, that should be a negative number. And let's find the launch speed, which is Vx. Let's go to our Venn diagram here, and let's see what we can do. We're looking for Vx. We know what dx is. It's 238. We know what Vy initial is. That's 0. Shall I write that here on the left side of the screen? Vy initial is equal to 0, which means that this projectile is not launched upward or downward initially. It's just fired perfectly horizontally. We know Ay, and we know dy. To find Vx, we have to know time and dx. But right now we don't know the time. So let's go to the right side of this. Are we able to use these three values to calculate the time? And the answer is yes. If you use this equation right there, if you know dy, and if you know ay, and you know Vy initial to be 0, you can calculate the time. So what we're going to do is we're going to use this equation on the right. We're going to calculate time, and once we've done that, then we're going to use this equation that I'm putting a rectangle around right now. That's how we do it. Here we go. Vy equals Vy initial times time plus 1/2 Ay time squared. Vy initial is equal to 0 here. We're not always going to be able to do this, by the way. When we get to projectiles that we launch at an upward or a downward angle, we're not going to be able to cross this term off. But whenever we have horizontally launched projectiles, since the up and down velocity initially is 0, we will be able to cross that off. We said we were going to find the time that this projectile is in the air. Multiply both sides by 2, divide both sides by ay, take the square root of both sides. And that comes out to 2 times dy is negative 62. Again, it's negative 62 because we chose upward to be positive, which is also why the acceleration is negative, because the acceleration points down towards the ground. And when you type that in, I recommend that you do that to make sure that I haven't made a mistake. 3.56 seconds. That's how long this projectile is going to be in the air. Incidentally, if we had just dropped this projectile from that cliff, it would take 3.56 seconds to hit right down here at the base of the cliff where I'm drawing a dot right now. The up and down motion is not affected by the horizontal motion. Going back to this, what we said we were going to do is we were going to calculate the time, and once we had the time, we were going to use dx is equal to vx times time to find vx. Dx is equal to vx times time, which means that vx is equal to dx divided by time. The displacement in the x direction is 238 meters. We just found out the time that this thing is going to be in the air, 3.56 seconds. And that comes out to be some number of meters per second. Let's look at significant figures now. This initial dy, you can see I'm pointing in the upper left corner, was to two significant figures. And we used that when we calculated this time here. So we left an extra sig fig on here just to cover our bases. But because we used that 62 somewhere along the line, we do need to round our answer to two significant figures, not three. 67 meters per second.